Hey everybody, Math by the Moon here, growing a little scruff out. I got the kids running around in the house, my wife's at work, so it's just crazy. Wanted to get into solving some single variable equations for you for my Algebra 1 kids. I know that's coming up. So let me share the screen and start talking about some of the procedures. Yeah, there we go, right there. And we got single variable equations, some steps. So if you want to pause this video, write these down. This would be a good opportunity for you. I'll be kind of referencing this as we go through a few of the problems together. Some of you guys in middle school or in elementary school have played games like hands-on equations where you have the pawns and the number cubes and you have to move them around and things. And it's basically you have a bunch of legal moves that you can do to try and solve the equation and before you even know that it's an equation. So I'll be referencing these. So if you needed, like I said, pause it, you can write them down. First example I want to do with you guys is just a simple two-step equation. 10x plus 2 equals 72. You always look to see if you can distribute. And I drew this line down where the equal sign is because if there's any distribution or like terms on one side or the other, we want to try and push them together. So over here, if we had like terms where there are two numbers that we could add or two variable terms we could combine, we would want to do that. Same thing over here. But there is no distribution. There aren't any like terms. So the next part of this process would be to try to isolate the variable. Some of the times we got to get all the variables to one side, and in this case all the variables are on this side already. So what we want to do is we want to get this 10x by itself. So that means we got to get rid of the positive 2 by using the inverse operation here. So it'd be minus 2 on both sides of the equation, and what that does on both sides, it keeps it balanced. So that'll cancel this out, and we drop down whatever's left. The 10x is left equals 70. Okay, and I use the phrase inverse operation. The opposite of adding 2 is subtracting 2, and that cancels it out. Here, the operation that's between the 10 and the x is multiplication, so we need to do the opposite of multiplying. If I read this to you, it says 10 times some number equals 70. So what I want to do is I want to get rid of the opposite. I want to get rid of the multiplication. And just saying that sentence, you probably know the answer already. You know the answer is 10 times 7. To show it algebraically, what we do is we divide both sides because we're doing the opposite of the multiplication. We divide both sides, and the only thing that's left over here then is x, and it's really a 1x because 10 divided by 10 is 1. 1x equals 7. Okay, now the nice thing about equations is no matter what, your answer better be really the answer. It better work when you plug it back in. So one thing to do to check it is to take this 7 and stuff it back into the equation and then do the math. Do 10 times 7, which is 70, plus 2, which is 72, and that's true. 72 does equal 72, so we know that this 7 is the correct answer, 100%. This next example is very similar to the one we just did, except there's an operation we're going to have to discuss. And when you have your graphing calculator, it's a lot easier. But when you don't have the graphing calculator, you might have to do it in 2 steps. So the first thing we're going to do is try and distribute and combine like terms, and we don't have any of that. And if you're wondering, I'm looking over here on these 2 steps right here. Then we got to move our variables all to one side. Well, all the y's are already over here on the left, so there aren't any variables we got to move to one side. And we want to move the constants. The constants are these numbers, so we're going to move this 42 over to the other side. So I'm going to add 42. And then recopy. 0 plus 42 is 42. And here's where if we had our graphing calculator and we could set it into our TI-84, we would just divide because this is a multiplication question. The unfortunate part is that you're sitting at home without your TI-84 and you probably have to come up with a way to do this without the calculator or just with your basic calculator on your phone or the one in Edgenuity. So I want to break this into 2 operations. I know that it's multiplying, but it's also dividing. This bar signifies division. So the first thing I'm going to do is I'm going to multiply by 13 on both sides. I'm going to multiply by 13. And now I'm going to have to grab my 42 times 13. I know 42 times 10 is 420. 42 times 3, and I could add it up, but 42 times 13, and I get 546 right there. And that 13 and this 13 are going to cancel out. And all that's left is 7 times y. So then to get rid of the multiplication, I can divide. And I know this is for my Algebra 1 class, and typically without this fancier calculator, we're going to do it in 2 steps so we don't mess up and get the wrong answer. So 546 divided by 7 is 78. If you do have access to a TI calculator, the easiest thing to do would be to just simply take that and divide by 7 over 13, or multiply by the reciprocal, 13 over 7. And you can do that all in one step. So it would be 42 times the reciprocal of 7 over 13 is 13 over 7. Notice how I put it in parentheses right there, and I'll still get the 78. So yes, you can do it in one step, but if you're struggling because your calculator isn't what you need it to be, you can do it in 2 steps. So we multiplied by the denominator first and then divided by the numerator second in 2 steps. So again, we could take this and we could plug it back in and check, and I'm going to save that for another time, but it will end up equaling over here 0. Some more examples that I'd like to show you get us, kind of full circle with all the steps. So the first thing we look for is any distributive property. We don't have that. Then we look for like terms. These are not like terms and these are not like terms. So then we're going to move all the variables to one side. And it's not as simple as just move it. You have to add the opposite. So if you want to move them all over here, or if you want to move these over here, that's typically up to you. Now, when we solve inequalities later, when this is not an equal sign and it's a symbol, I tend to tell kids to take the variable that's over here on the right and always move it to the left, just because it makes your analyzing the answer at the end easier understood, because you read it from left to right. So the variable should be on the left. So we're going to do a plus 5x here, and we're going to do a plus 5x over here. That way all of the variables that were over here are now going to be on the left side. So we'll take -3 plus 5x and we'll get our 2x, drop down everything else that we didn't touch, and this canceled out. And this is a -17. Watch your signs. So now we're right back in the same game we were before in our first 2 examples, where we had to get this 5 over to the other side, and then we had to get rid of the 2. So it's a -5. All right, and a negative plus more negatives makes bigger negatives. And then we're going to divide by a 2. And again, if I wanted to guarantee this was my correct answer, I'm going to have to plug it into both locations, into all locations where the variables would be, and do the math over here. -3 times -11 plus 5. -5 times -11 minus 17. And whatever number I get over here, I should get the same exact number over there. And that guarantees I'm accurate, that my answer is indeed the correct answer. For my last example here, I'm going to show a problem that just does it all. It has a little bit of distribution, combining like terms, variables to move to one side, the whole works. So we draw our line and we look at each side, and I know I have to distribute because I have multiplication with a set of parentheses here, and I'm going to do it on both sides simultaneously. So this would be 18x, and it'll be -2, got to watch out for your signs, plus 5 equals, this will be 42 minus 7x. Now, careful, this 7 doesn't distribute to the 11. I almost did it on accident. It won't. The 11 will just drop down, just the same way that this 2 didn't push over to the 5 either. So now, after we distribute, we want to look to see if we can combine like terms over here. So I have a -2 and a -5. They're both constants. I can combine those. 18x plus 3 equals, and over here I have a 42 and a positive 11. So I can make that, well, the -7x doesn't go with them, but 53 is 42 plus 11. minus 7x. And now, just as we did in the previous example, after we distribute and combine like terms, we want to try and move all the variables over to the left, okay? That's my personal preference. You can move them either direction, but I'm going to try and move them over here to the left. So that means the variables on the right side are going to cancel off by adding 7. That leaves me with 25x plus 3 equals 53. And now we're right back where we were in the first two examples. We're going to subtract 3 and isolating this 25x all by itself equals 50. And then divide by 25. And we get x equals 2. And just to reiterate the idea of an equation is that if I sub this back in to both sides over here, if I put it in up here, I'm going to get a number that I get the same exact thing. If I plug that 2 in right here, I'm going to get the same exact number on both sides. So that's how we guarantee that we are correct. So in most cases, that's just me punching this right into the calculator and hitting enter right here to see if I get a certain number, and then typing the same thing in over here with a 2 in where the x is and seeing if I get the same number. And then I know I'm right. So using your inverse operations, going back to these steps, if you need to jot these down, here they are again. But let me know if you need any help. I'll be adding some other videos today that hopefully can help you in some other areas in Edgenuity. So later.